Okay, so yesterday we did cosine, sum, and difference, right?
Yeah.
Today's sine and tangent. So if you're okay with it, I'll just show you the sine formula. Just write it down, talk through it, not show you an example, because it's very similar to cosine. Is that okay?
Do it. Yeah.
I thought you said sum is what gets everybody mixed up.
Tangent is the one that we want to make some, pay attention. Okay, so the sum identity for sine. Is yeah, it's sine fishy plus cosine taily. No, it's alpha and beta.
What did you call
Caleb wouldn't know that.
Taily, fishy and taily. I couldn't come up with anything more original than that. Taily. Yeah. Okay. Anyways. Okay, that's the sum identity for sine. Notice the signs match this time, right? Okay, and cosine are opposites. And also notice that sine and cosine are with each other, whereas with the cosine identity, it's cosine alpha, cosine beta, right? So just a little bit different. Again, write this on your blue sheet for your test. I'm not going to require you to memorize it. Okay.
What's Tom?
Hand. Okay. You can also do the difference identity. It's really easy to write down. There's the sign difference identity. Okay. And remember, we're just adding and subtracting up angles to make unit circle values. So before we had calculators, this is how people did odd funny angles with the unit circle. Okay. That's where these come from. We use them as to make you think. So, sounds like you're looking at your papers, walking around, and talking to you. It sounds like you'll be okay with that one. Okay. But there are two examples in the book, if you would like to see them. Okay, here's the awful one that we got to talk about. It's not awful, it's just a lot of arithmetic. Okay, let's put it that way. I have to do arithmetic, it sucks. Shut up, Richard.
Anyway.
Will you sit down?
I started back away.
I know what you were doing. You're being disruptive. Okay, there's the sum identity for tangent. You notice it's a fraction.
That makes sense.
Right, so we're going to have some common denominators to find. We're going to have some fraction division to simplify. Okay. With sine, you're still going to get a lot of root 2, root 6, root 3 answers. With tangent, that changes a little bit. Okay. And then, what?
Are they not tangents multiplied?
Yeah, those are multiplied together. If you want to do the difference identity for tangent, make sure I'm right here.
That'd be great though.
That would. Just like 1 over 1.
That's what you're looking at. Okay. So, again, same concept in building the formula. What you're looking at is just a little bit more arithmetic out in the back end. You okay with that?
So does the sign after the one, does that depend on what the sign is in the
Yeah, so if it's a sum identity, addition, that's plus and that's minus. Yeah. If it's difference, you have minus and plus. Yeah, pay attention. The signs are where people incorrectly write things most of the time. You just make us stupid, right? Stupid human tricks is what we call those. So, let's calculate the tan of 285. Can you think of a couple angles that add up to 285 that are on the unit circle? 270 and 15?
Yeah.
Is 15 on the unit circle?
No.
It is not. Okay?
Add some 285.
Hey, I'm looking at you.
225 is 60.
Okay, that's a good suggestion. Right? 225 plus 60. So, build your formula. Tangent 225 plus tan 60 over 1 minus the two of them multiplied together. You good with that so far? All right. Now we got to find the values of those off the unit circle, right? That requires you a little bit of thinking. Tan of 225. Bingo.
What'd you say?
1.
1.
He said 1.
She said 1.
Oh, she did?
No, she said 1.
Oh, she said 1. Oh, okay. Okay, tan 60. So remember, tangent is just the y over the x. Correct?
Yeah.
So again, if you have a 60-degree angle, cosine's 1/2, sine's root 3 over 2, divide.
It's root 3.
Yep. Root 3 over 2 divided by 1/2.
Why is tan 225 1?
Good question. I will answer that. Okay. 225. Right there, yeah? There's your unit circle. Please excuse the ugliness. I know it's present a lot in this classroom. The values for cosine and sine,
Oh, okay.
right? They're the same. So divide,
Yes.
and you get 1. Okay.
Okay.
So your options for tangent are 1 or -1, root 3 or negative root 3, or negative root 3 over 3, and root 3 over 3. Those are your options. Okay. So not a lot of options. You just have to figure out which one you got to use.
So it's for this one, the answer is just 1.
Do we have some sort of a preference in mathematics about roots in denominators?
What is it? What is it?
Good. It's like snow on the ground and everybody goes crazy.
It's more.
Do I like having roots in the denominator?
No.
Okay.
So you have to
How can I get rid of it?
square it.
Squaring that will leave roots in the denominator. Not a bad thought, but if you square it, you have to FOIL the 2, and it leaves that in the middle term. Okay. You have to multiply by the conjugate. Have you ever heard that before?
Yes, I have.
You should have. Okay, that's the conjugate. Okay, I'm going to spell that right. They differ by a sign. Remember the difference of 2 squares? If they have a different sign, the middle doesn't exist. Okay, the middle's gone. So we won't have the issue that if we square it, right? So for the top, we can just write this, just to make our lives easier, because we don't need to worry about it. What's the bottom become?
Wait, why is it a subtraction if it's a multiplication?
Well, doesn't it eliminate one, so? Oh, wait, never mind.
Say that
Yeah,
again.
need one
And
plus
the
three.
one above it is 1 minus 1 times root 3.
No, this is 1 plus root 3 times
She's
1.
talking about the one above
that.
That's for the denominator.
Oh, what's 1 times root 3? Well, yeah, root 3, so. Okay. The bottom, FOIL it out. It becomes 1
Plus 3.
minus
Plus
root 3 squared. If you FOIL that out, that's what you get. So you get negative. There's your answer. A little messier.
Would we not solve the top?
Yeah, you don't need to. This numeric value is no different than if you FOIL it out.
Wait, why is it? Oh.
As a decimal, they're the same, right? Whether you FOIL it out or not.
Should it be negative 2?
It's just more work. It is
Oh, okay.
Oh,
negative. Yeah, remember you can write negatives out front or on the bottom or on the top. Okay, so that was a more straightforward tangent. There are no fractions. You want me to show you a fraction one?
yeah, let's do it. You only live once.
You only That's not a phrase that we usually use in math class. Let's see if I can find one.
Well, mathematically, you only live once.
We're just gonna let that one go. Let's see what I'll make sure I don't do one of the homework assignment problems.
Dang it.
I did that yesterday on purpose. So. Showed that some of you were very observant. 15, 17, 21, 25.
15.
Sweet. We're going to do number 20. Tan of 165. I think it'll work out. Okay, two numbers, add or subtract. Is that right?
135.
Okay. What is the tangent of 135?
Tangent at 135 is root 2
Negative 1.
over negative root 2. Root 2 over root
Negative 1.
Negative 1.
That's true.
Okay. What's the next term in this? Plus?
Yeah.
And then tan 30?
Tan of 30 is.
Should be root 3 over 3.
Yeah.
Okay. Tan at 30, here's how I get root 3 over 3.
I understand
Yeah, well, I'm not talking to you then. That wasn't a roast, it was just a fact. Okay. Tangent at 30 is 1/2 over root 3 over 2, right? Okay, so copy dot flip, you got your fractions. Do I like roots in denominators? No, so we have to multiply by root 3. And you get root 3 over 3. Which makes our lives a little bit harder, but we can still deal with it. The nice thing about these is that the bottom terms match the top terms, right? So we got tan 135 plus tan 30, 1 minus tan 135 tan 30. Okay. And we need common denominators here. So tell me if this makes sense. What's -1 as a fraction in thirds? -3 over 3, right? There you go. And then root 3 over 3 is here. And then we got 3 plus root 3 over 3 as well, correct? Common denominators. Oh, glad you look confused.
Yeah.
Okay, we need a common denominator of 3.
Yeah, I get that. So I'm going to definitely -1.
Oh, if I needed to put that as a fraction over 3,
Yeah.
what would the top be? Got it, okay. Now we can do our fraction multiplication, right? That should be plus. And then we can cancel, right? And we're back at the same place we were with the last one at this point. Nope. You can't. Why can I not simplify this by crossing out top and bottom? Yeah, the negative's with the 3. If that were true, -1, because then top and bottom cancel, right? But they're different. So we cannot cancel anything out. Right. What do we have to do now?
Do it by multiply by column.
Yeah. Boom. Boom. The top, are those the same? No, they're not. So we're going to multiply it out this time. The bottom becomes, the denominator is 9 minus 3. 3 times 3 is 9, minus that. And then the top we have -9. Plus 3 root 3. 3 minus 3. -12 plus 6 root 3 over 6. And we can simplify that to -2 plus root 3. Whew. Lucky this ran marathon. Which has never happened. So I wouldn't even notice like.
Wow, that's our answer.
Lots of simplifying arithmetic. Plugging in is not hard. Even the unit circle values, you're pretty good on those. Just make sure your math turns out right. Stay organized, stay neat and clean. Okay.
Now apply to the drugs.
Follow your own advice.
Stay frosty.
Frosty. Okay, any questions? No? All right. I'm going to give you some time to work here, so take advantage of it.
Wow, that's nice. Thank you.
Thank you for complaining. Have the world.
That looks like double
And beyond.
Thank you, Buzz.
Wait.
Do you think I'm really serious?
That says wait.
Come on, 64 to infinity.
Yeah.
Maybe.
If you fall for that,
Wait.
well, look at that sky. Talk about blue. And you look up. Okay, thank you for that.
Why is there so much?
Who looked up?
I can't kid with you guys at all when it comes to homework.
It's like 3:30. It is not a joke.
You know, it's not a joke. Answer.
Your face. No, wait, never mind. I guess I was wrong today.
Answer not a joke. Yeah, she just said a naughty word.
I didn't hear it.
Oh, snap, that's awesome.
I didn't hear it. I'm on it.
Oh, I thought you were-
What?
No, I didn't hear it. Like, all I heard was a murmur. Sorry. You should take the plank out of your own eye before correcting the speck in hers.
Family from Louisiana.
One of my clusters.
Is that something else?
I don't know, you could probably answer that question better than I could.
I'll give you a cluster.
All right. Okay, one more note. What happens if you see this? How do you deal with this one? 1 over.
Yes.
Yeah, you're gonna do 1 over and then the cosine identity, and then you're gonna just do your fraction. Okay.
So you just
Is it
plug
Friday?
Friday.
cosine 165.
This?
Better not be.
Make it do Friday, please.
Yeah, make it do Friday.
Dead. Or just on a sock.
Kel, will you answer that? Please. Thank you. So here's, I'm considering your request.
All right, is everywhere. Oh, let me come now. David, your spell.
Oh, wow. Already.
actually got
Okay,
down, they actually-
tomorrow
hilarious.
we have new stuff. But Friday we're playing a game with no homework Friday, so I can have this due Friday and tomorrow's stuff due Tuesday.
That would be.
Yeah.
You hear that? All
I
right.
don't got that with my pen.
But you gotta work for the next 15 minutes or I'm gonna take that away.
I was about to say, now it ought to.
Thank you. You're welcome.
Thank you.
Happy Christmas.
Do you want a hug?
All right. So get to work or I'm gonna take that away.